All right, dudes, welcome back. So today, as promised, we're going to be solving more triangles, but we're going to be doing the SSA case, which is going to be a little trickier, okay? But I'll show you what I do, so I don't necessarily have to rely so heavily on the book, because I have a feeling if you look at the pages that I sent you in the book, there's a chart that tells you exactly what to do. It's kind of like not really a flow chart, but it definitely has all the different pathways, and there are literally 6 different options you have to look at, okay? So it's going to be kind of involved. I like to break it up into 2 cases. So this is SSA, that means side angle, and it means they're only giving us one angle. Remember the last problems, they gave you 2 angles, which was really nice because then you could easily find the 3rd angle and only use the law of sines, okay? But in this case, we've got kind of a lot of work to do, okay? If the angle is obtuse, this is one case, then I'm going to show you what to do if the angle is acute when they're only giving us the one angle, okay? And then that branches off into 4 different pathways, but it's just kind of madness. So here's what we do. Check this out. This angle that they give us, in this case it's obtuse, what I like to do is draw a picture of that obtuse angle, and I always put it in the bottom left of my triangle. So here's about 115 degrees right here, 115, and this is angle A, okay? All right, so that's the first part. Then if you look, side A should be across from it. So this is going to be side A way over here. I'm not going to draw it yet though, okay? And this guy right here is side B, that's 11. So you could put B here. I like to put it here, okay? This is where my side B is. That's going to be 11, okay? Now watch this. Ready? If it takes 11 units to go from here to here, right? Would it take more units or less units to walk from here all the way over to here? I hope you said more, right? The distance from here to here is 11. Is it possible that the distance from here to here would be less than 11? No, it's impossible. So the distance from here to here has to be greater than whatever this distance is, okay? So that means if B is 11, okay, and if A is anything less than 11, let's just say A was 10, okay? Well, if this from here to here is 11, then wouldn't it be from here, trying to get to that other side, we'd have to stop right about there. That would be 10, wouldn't it? Okay, it wouldn't make a triangle. So if A is smaller than this B, you're not going to have a triangle. Luckily for us, though, A is 20, and it will reach all the way over to here. Okay, so here's 20. Okay. All right, so we've got our triangle set up, and now we can use the law of sines. So keep in mind, this is B, okay? So this is angle B, all right? And then this has to be side C, and then this is angle C, all right? Okay, let's use the law of sines. Here we go. We know that the sine of 115, right? The sine of 115 over the opposite side, over 20, is going to equal the sine of B, right? So the sine of B over the opposite side, 11, okay? All right, so let's get to calculating. Here we go. We need that sine of 115, so sine of 115, okay, that equals 0.906. I'm going to multiply the 11 to it, okay, so times by 11 equals, and then I'm going to, did I say times? Good. And then I'm going to divide by 20, okay? So, let's see. So the sine of B, okay, so the sine of B is equal to 0.498. So 0.498, all right? We want to solve for B, right? So if I want to solve for B, I need to move that sine over to the other side. Remember, you take the sine of an angle, but you take the inverse sine of the ratio. So if this is my angle, it's going to equal the inverse sine of that ratio, 0.498, okay? So now I need the inverse sine of that. First thing though, check your check your mode. You want to make sure you're in degree mode. We are, okay, so I'll get out of there. So I want the inverse sine, so inverse sine of 0.498, and I'll go a little more, 498, 4692, 4692, okay, enter. I get 29.9 Let's just round it to 29.9, okay? So B equals 29.9, almost 30 degrees. Which makes sense because the ratio is almost 1/2, right? Isn't the sine of 1/2, or the inverse sine of 1/2, 30 degrees? Or in other words, the sine of 30 degrees is 1/2. Okay, so that makes sense to me. I like it. All right, so now I know that angle B is 29.9. And now let's subtract those guys from 180. Okay, so 180 minus 115 minus 29.9 equals, that's 35.1. So we have 35.1. Now all we have to do is find side C. So here we go. Let's set it up. I'm going to use the same ratio. Okay, so sine of 115 over 20 is equal to the sine of 35.1 over side C. Okay, I see my C is down in the denominator, so I'm going to flip everything. Okay, so this is 20 over the sine. I'm just going to write it all down. Okay, equals C over the sine of 35.1. Sorry if my writing's getting so sloppy. It's really looking sloppy, isn't it? Okay, well, anyway, here we go. So I'm solving for C. So I'm going to multiply sine of 35.1. Okay, let's see. So sine of 35.1 equals, okay, now I'm going to multiply it by 20. So times by 20. Okay, and then I'm going to divide it by, okay, and I'm going to put parentheses just in case, the sine of 115. So the sine of 115, okay, equals, and I get 12.69. Okay, so C equals 12.69. Okay, so 12.69. And I'm just going to check, okay, where's my smallest angle? Right here. That's my smallest angle. It's across from my smallest side. Okay, where's my biggest angle? Right there, it's across from my biggest side. Where's my middle angle? 35 across from 12. So it looks like I did it right, okay? So that's the first case. That's when the angle is obtuse. So remember, if the angle is obtuse, okay, this side has got to be bigger than this side, okay? If it's shorter, you're not going to have a triangle. Okay, so that's that. Now let's do part D, solve SSA triangles. So part D, solve SSA triangles, okay? But this time when the angle is acute. And here's where it gets a little stickier, okay? All right, here we go. Clear off my calculator. So here's my first example. B is 2, okay? C is 4, and angle B is 50. Okay, definitely acute. All right, so what I like to do again is put that angle right there in the left corner, so 50. I'm going to try my best to make a 50-degree angle. It looks something like that. There's a 50-degree angle, more or less, okay? All right, and then I know this says side B and C, but if this is angle B right here, if that's angle B, and this is another reason why I don't like to look at that chart they give you. It's because they use A's and B's and C's, and it's just like, it's so confusing with all the letters, okay? So here's my angle B. So the side across from it, this guy's got to be my side B. This is my 2. So I'm going to put my 4 right here, okay? And now look, will a 2 stretch all the way down to here? I don't know, okay? Will a 2, who knows? Okay, so here's the thing. This is what you have to do anytime you have an acute angle. Anytime you're solving a triangle and they only give you one angle and that angle is acute, you first have to find the height of this triangle right here. We have to find this height right there. Okay, we'll call it H. All right, so this is our first step. We have to find that H. So how do I do it? Well, if you think about it, here's my angle, okay? If this is my angle and this is the side opposite the angle, and this is a right triangle, so this is the hypotenuse, isn't it true then that the sine of 50 is going to equal this height of the triangle divided by the hypotenuse 4? Okay, so watch this. Take the sine of 50. Sine of 50 equals 0.766, okay? Move that 4 times that 4 to the top to get the height, right? So times it by 4, okay? And that equals 3.06. So my h equals 3.06. So this guy right here is 3.06. Okay, so watch this. Here's the idea. To go from this point down to this point, that's the shortest distance, right? It has to be the shortest distance. That's 3. If I wanted to make a triangle like out to here, wouldn't the distance from this point down to this point here have to be longer than 3? The shortest way to go from this point up here down to the bottom is a perpendicular line, and that line is 3.06. Okay, well, we already know this is 4, right? So this line has to be 2, but look, 2 is shorter than 3.06. What does that tell you? No triangle. It's not possible. There's no triangle right there. It's not possible, okay? All right, let's try one more. All right, let's try. Let's try one more, and then I'm going to leave the rest of the notes up to you. The rest of the notes is finding areas of triangles, and the formulas in the book. It's really simple. It's really straightforward, okay? Promise. I'm not going to have to show you the notes, okay? I have just enough time for one more of these examples. Let's try it. Here we go. I know that angle C is 7. Oh, no, I'm sorry. Sorry. I'm wasting time here. Okay, my bad. Now I'm racing the clock. I'm getting nervous. Okay, here we go. So side C is 13. Okay, side A is 16. And angle C is 40. Okay, so here we go. I like to draw a picture and put that 40 right down here. Okay, to the best of my ability, I'm going to draw a 40-degree angle. Looks something like this. Okay, that's a 40-degree angle. Okay, angle C. Side C, 13 would be across from it. It would be over here, right? So I'm going to call this guy 16 right here. Okay, now remember, we have an angle that is acute. What do we always have to find? We have to find this height first. Okay, because I don't know, will 13 stretch all the way down? It looks like it, but I don't know. Okay, so let's find this guy first. Okay, so now let's figure that out. So we have the sine of 40 equals this height over 16, the hypotenuse. So sine of 40 equals, times it by 16, and that height is 10.2. So this guy is 10.2. Okay, the height is 10.2. So now, the shortest distance from here, perpendicular down to the base, is here. That's the shortest distance, okay? So if I wanted to go out here, that would be longer than 10.02. So there we go. We have this guy right here. This guy is 13. It will fit, but there's a problem. Notice this guy right here. Couldn't I also draw a line this way and get a 13 there? Okay, so look what I have. I have two triangles. I have a triangle here that's 40 degrees right here and 16 units there, and then 13 units here. And then I also have this triangle here with a 40-degree angle, which is 16 units long there, but 13 going this way. See what's happening? Think about that for a second. We ended up with two triangles because this height is 10, so that means 13 can fit this way or 13 can fit this way. Youch, okay? I'm gonna stop the video really quick and I'll continue this, okay? All right, see you in a sec.